a lobule. So the lobule has a center. Is that here or here? This is the center. So this vein is the central vein. So from here, there's going to be 6 sides to this hexagonal unit and 6 corners. So here's one corner, right? And then there's going to be another, and another, and another, and another, and another, and another. So it's going all the way around, right? This lobule. So we've made a section through part of it. This red vessel, plus this blue vessel, plus this green vessel, 3 of them together form the portal triad. The red one is, so probably not best to call it hepatic artery proper, although it is a branch of hepatic artery proper. But these really small branches that come off of it that we find inside of the liver have a better term. Portal arterial. And then speaking of, can you hand that to me, please? I'm close, but thanks. So, big picture, macroscopic now. This is hepatic portal vein, and this is hepatic artery proper. So we're way downstream from those vessels, looking at microscopic branches off of them. And then we've seen that the arterial blood and the venous blood mix together, and they both end up passing through these blue vessels called sinusoids or sinusoidal capillaries. While blood is going in this direction towards the central vein, bile is going in the opposite direction towards the triads. Bile first collects in a system of tunnels surrounding the hepatocytes called bile canaliculi. And then from the canaliculi into these little tubes called bile ductals, into this larger tube, bile duct. Just bile duct. Right? Not common, not cystic, not hepatic, just bile duct. There's a 4th vessel right here. This vessel that's yellow, we would normally color green in any other model, but which we already used green for bile. So normally what is green used for? Lymphatic. This is a lymphatic vessel. But they had to use a different color, so it's yellow. But they don't count lymphatic as part of the triad. So a triad is just the arterial, the venual, and the bile duct. All of these brown structures are hepatocytes arranged in plates with the sinusoidal capillaries running through. After the blood leaves the central vein, where does it go next? Interlobular veins, which are found in the interlobular septa surrounding the lobules, and then from there into the hepatic veins, which we can see leaving the liver going into the vena cava. So they didn't distinguish it with a different color, but right here is a sheet of connective tissue called falciform ligament. Right. And then this cord-like structure that extends from the falciform ligament all the way down to the umbilicus. Round ligament or ligamentum teres. This whole section of the liver is the right lobe, left lobe, and that's all you can see from this view. From this view, you can also see this quadrate lobe next to the gallbladder, and this caudate. So this is all caudate, right next to the vena cava. So that's it for this. Kidneys on the back and adrenal glands on top. Vena cava, abdominal aorta. What's the green thing here? Gallbladder. Coming off of the gallbladder. Cystic duct. These 2 branches. Left and right. Hepatic ducts. They merge and form this very short common hepatic. It merges with cystic and forms common bile, which you can see better on the back side. So that's all common bile duct there. And it goes all the way through, comes out the other side, and then it joins up with main pancreatic duct. They come together in the wall of the duodenum in this widened region called hepatopancreatic ampulla. It's surrounded by smooth muscle fibers which form the hepatopancreatic sphincter, or sphincter of Oddi is the old name. And then it continues and forms this little projection, this little mound of tissue that pokes into the lumen of the duodenum, and that is duodenal papilla. And you can even call the ampulla duodenal ampulla as well. And then up here, accessory pancreatic duct. What do you call this material? So it's in the lumen of the small intestine. Chyme. These ridges in the wall. Plicae circularis, or circular folds. Don't need to worry about the blood vessels. This is the head of the pancreas and the body and the tail. That's it for that one.
Stop.
It's what?
The folds. So notice how the wall's kind of thin here. It's thin up here, but really thick down here. What's this really thick area called in here? Pyloric antrum.
Is it like backward?
What's this right here? What's this part of the stomach here? So what's this? Esophagus. This? Duodenum. Yeah. I can't really see much of a sphincter with this guy. But the sphincter would be in this area roughly. So yeah, esophagus, duodenum, fundus, body, pylorus, pyloric antrum, pyloric canal. Lesser curvature and greater curvature. Healthy liver? Not so healthy liver. It looks like fatty liver disease, but it's also labeled as liver with cancer, so perhaps both. Did you see any idea what this is? Cecum. So they've cut a little opening so you can see inside. And there's a little slit-like structure right there. What is that? Ileocecal valve. You can also see it from the ileum side. So this is the ileum. And that would be the ileocecal valve looking at it from the other side. So take a look at this at some point. It's very similar to an image that we had in our book. If you have the cecum, then what else should you have in this model? Or this specimen?
Appendix?
Right, so here's the little out-pocketing. It kind of goes up like that. It's vermiform appendix there. So you have, here's some plicae in your ileum here. So a little window cut open, you can see inside. So cecum, ileum, appendix, ileocecal valve. All of that can be seen. This is what part of the digestive tract? Small intestines. What gives it away? Villi. And the villi have their lacteals. This pink layer here. So everything above that is part of mucosa. everything below it to the next layer of smooth muscle, submucosa. This next layer is circular layer of muscularis externa, and then longitudinal layer. Together, that's muscularis externa. Third tunic. Fourth tunic is this. So the serosa consists of two things. The yellow is areolar connective tissue, and the pink, it's a simple squamous epithelium. What's its name, special name? Serosa is visceral peritoneum. Visceral peritoneum is a serous membrane. What do you always call the epithelium of a serous membrane? Mesothelium. Right? And a serous membrane consists of two things: underlying layer of connective tissue, areolar, and a simple squamous epithelium called mesothelium. What would you call the areolar connective tissue up here? Lamina propria. Because up here it's part of the mucosa or a mucous membrane, and that's the special name for areolar in a mucous membrane, lamina propria. What type of epithelium? Simple columnar. The pink cells, which are the most abundant ones, most of them are. Absorptive cells. The blue? Goblet cells. This blue structure? It's part of malt, or more precisely part of galt. But galt is all the mucosa-associated lymphatic tissues. This is just a structure called lymphatic follicle, lymphatic nodule. From muscularis mucosa, there are smooth muscle fibers that go all the way up into the villus. Their job is to make the villi wiggle, move around all the time, constantly mixing luminal contents around them. Lacteal collecting vessels is all of this. How about all the yellow? It's all nerve fibers. So if you're looking at the yellow in here, that would be part of submucosal plexus. The yellow between the two layers of muscularis externa, myenteric plexus. Together they form enteric nervous system. This gland here, and here's another one, and from the side, here and here, you can call them mucosal glands, but better known as intestinal crypts, and I often call them intestinal glands. Crypt is the most common term in the book and the keys. Do you have submucosal glands here?
Mm-hmm.
This is a giant gland right here. It is. Old name? Brunner's gland. And that's what it'll say on this particular key, Brunner's gland. That is one giant duodenal gland right there. So this is what part of the small intestine? It's got to be duodenum, because nowhere else would you see these big submucosal glands. I think that's everything. The yellow here? Okay, if I asked for type of tissue, adipose, what's the name of the structure? Greater omentum. This is the beginning of what? When I pull this out, I can't pull out the duodenum. It's adherent to the dorsal body wall, but I can pull out the rest. So this is the beginning of jejunum. And this is the end of ileum. So this whole thing is jejuno-ileum. Same thing here, jejuno-ileum. This cut edge of connective tissue is the cut edge of what? What do we cut there? So we can pull this out of the body.
The part where the attaches to.
It's a mesentery. It's attached to jejunum and ileum. This is mesentery proper. So all of this connective tissue is mesentery proper, but where it's been cut right here, that's the root of mesentery proper. So right where it attaches to the dorsal body wall, that's where we cut it. So this goes together like so. So what's this section here? Transverse colon. And the yellow here? It's part of greater omentum. So it started at the stomach and went down, it turned up, and it came back and attached to the front top surface of the colon. What is this back here? It attaches the transverse colon to the dorsal body wall. That's transverse mesocolon, what I'm holding on to. And then this is greater omentum. And each one of these little pockets, hostrum, plural, hostra, the band going across here, there's one over here, tenyae coli, which is a band of what? Longitudinal smooth muscle. So this would be the cut edge of transverse mesocolon. We pulled jejuno-ileum out, and what we still have attached to the dorsal body wall is duodenum. Right? It's behind the peritoneum, so it's retroperitoneal. Same with the pancreas. What's this connective tissue right here? Mm-hmm. And then this S-shaped part of the colon, sigmoid colon. And this sort of pale color here, it actually should be anus. So what's missing? They went straight from sigmoid colon to anus. There's no rectum here. I think they intended for this to be rectum in here, but there's not much of one. So what's this? And here? And the beginning of the large intestine is this cecum. And this little slit here, ileocecal valve. So this part of the intestine is ileum. And this green thing hanging down? Appendix, vermiform appendix. And this is the cut edge of mesentery proper. Right? It's going to fan out and attach to jejunum and ileum. This white thing here, main pancreatic duct. Yeah. And they've got this little white colored tube inside of the duodenum. There shouldn't be a tube in there, just a little mound of tissue. Yeah, they should just have a duodenal papilla. That's a little much for a duodenal papilla. This green thing on the back here? Yeah, common bile duct. Is it time? No, we're good. More of the same here. Duodenum, plicae circularis, the yellow inside, chyme. The brown inside, probably getting close to feces at this point. This here, ileum, and this cecum, and this little slit here, ileocecal valve, and this structure, that's the appendix. You can see duodenum, pancreas on the back there. Tenyae coli again. The white covering to the stomach here. Serosa. The yellow attached to the greater curvature. It's part of greater omentum. from the outside, it's hard to tell what's jejunum, what's ileum. It's all kind of coiled together. But if you can peek inside, you can figure it out. There's one, part of 2, 3, maybe 4 little ridges here. Here there's like 8 really deep ridges. So what are these little ridges that are more prominent here than here? Plicae circularis. So where it's more prominent, this must be jejunum, and this must be ileum. And you've got mucosa, white, submucosa, blue. The 2 pink layers are muscularis externa, inner circular, outer longitudinal, and then the covering, serosa. All these little yellow things hanging off the colon. Fatty appendages, fatty appendices, epiploic appendages, or epiploic appendices. This fat here is part of greater omentum. This connective tissue, transverse mesocolon. This 90-degree turn right here, left colic flexure or splenic flexure. And then this 90-degree turn right here, right colic flexure or hepatic flexure. What parts of the colon are in the peritoneum and have mesenteries attached to them? Transverse colon does, sigmoid colon does. Ascending, descending, they do not. What's on the back here? Duodenum. Innermost layer of muscularis externa. Oblique. Superficial to that. Circular. Superficial to that. Longitudinal. So there's a sphincter, a very small opening in there. So what sphincter's right here? Pyloric sphincter. If you look here, you don't see much of a sphincter at all. It's very ineffective as a sphincter or valve. But what do we call it?
Gastroesophageal.
Cardiac, gastroesophageal, cardioesophageal, or lower esophageal sphincter. Although it's not really a strong sphincter at all. We could probably come up with a few more. So this white serosa, this thing sticking out right here, it's part of a stand. Goes on the little metal rod. All right. Gastric stand slot. I'll work on a name. Sphincter. Pyloric. Ridges. Rugae. Same 3 layers of muscle again. This. Duodenum with the plicae. And the green here and here. Common bile duct meeting up with main pancreatic duct. The only model that actually shows the ampulla in the wall was that first one I showed you. And I think I put it back over there, but it's the newer model with the spleen and pancreas and all that good stuff. Head of pancreas, body of pancreas, tail of pancreas. This here,
Salivary, no, parotid.
parotid salivary gland, submandibular salivary gland. Don't see a sublingual here. But what's this orange tissue here? pharyngeal tonsil. And what tonsil's right here? Tubal tonsil, and right here? Palatine tonsil. And then right here on the base of the tongue? Lingual tonsil. And then this little groove here? Separates the root of the tongue from the body. Terminal sulcus. If we were looking at the dorsum of the tongue, just looking over the top of the tongue, which papilla are just anterior to the terminal sulcus? And they almost form a V right in front of it. The valate or circumvallate papilla. So I didn't bring it over here, but don't forget to review that tongue model. There's some things on there you need to know. It also shows the sublingual gland on that model. This tissue here, soft palate, the little thing that hangs in the middle there, uvula. That's pretty good. Oh, I had two of these. So yeah, it's this model that shows the hepatopancreatic ampulla. It's the only one that shows it. This space here. The space here. Right? All the white. The black. Cavity. Dental carie. These little tubules. Dentin. Where the enamel stops, what becomes the surface material of the tooth?
Cementum.
Cementum. What attaches the cementum of the tooth to the bone?
Periodontal ligament.
Periodontal ligaments. All the pink.
Pulp.
And a little inflammation there. And pulp has nerves and blood vessels, but does not have lymphatics. I'll get on it, yeah. Eventually I'll fill that in. So all of these models go together. It's a set of 8. And the first thing I would look at is the tops of them. So this one you see villi. This one, no villi. This one's nice and flat. Definitely no villi. Kind of bumpy, but still relatively flat here as well. So the one with villi must be small intestine. Then you got to figure out what part of the small intestine. There's a few things you could look for. You might just go straight to the bottom of the model. Look for that outermost tunic. I don't see a simple squamous epithelium here. I only see connective tissue at the bottom. So that means the outermost tunic is adventitia. What part of the small intestine has adventitia?
Duodenum.
Only the duodenum. There's a second thing that the duodenum and only the duodenum has, which you can see. There's lots of them here. Submucosal glands, called duodenal glands, all of the green. What are the white cells here? Goblet cells. All the other cells? Absorptive cells. Now when you get way down here into the mucosal glands, you're going to find some other cell types like enteroendocrine cells, Paneth cells. And what do we call these mucosal glands down here? Intestinal glands or intestinal crypts. Okay. So we look at the top of this one, like the other, villi. So we know small intestine. Try to figure out what part. You look at the bottom, there is a simple squamous epithelium. So there is a serosa, it's not duodenum. What would you find in the ileum that is less, what would you find in the jejunum that is more abundant than in the ileum? Way more plicae circularis. But we can't rely on that for this model because we can't see plicae at all. So instead we have to look for something that you do find in abundance in the ileum, that you don't see as much of in the jejunum, and that is
Peyer's patches.
Peyer's patches. Big groups, big clusters of follicles. So I think we can probably assume this is ileum. That's probably what they're trying to show here with this big follicle. So we've got villi again, but then we've also have this flat surface. So I guess potentially it could be transition from small intestine to large, or it could be from stomach to small intestine. So probably the best thing to do is to look at this side, because we already know this is small intestine. We want to know, is this stomach or is it colon? Because from the top, it doesn't look all that different. They're both relatively flat, no villi. So the first thing you should notice here is this huge, thick layer of circular smooth muscle. Would you find that at the transition or the junction between small intestine and stomach, or small intestine and large intestine?
Small intestine.
The pyloric sphincter is by far the most effective sphincter, has the thickest layer of circular smooth muscle. I mean, this is super thick. So that's where we are here. We're at the pyloric sphincter. And the other thing we can look for to figure that out, if this was large intestine, then this would have to be ileum. Ileum doesn't have submucosal glands. Duodenum does. So it must be stomach to duodenum. And that's what it is. Serosa at the bottom. Right. So the serosa, at some point after leaving the stomach and moving on to the duodenum, is going to disappear. We're at the junction. It hasn't disappeared yet. So don't let the presence of serosa convince you that this can't be duodenum. We just haven't got far enough along. It will disappear. Flat surface, no villi, so it's not small intestine.
Stomach.
The epithelium is simple columnar, so it's not esophagus. Maybe stomach, maybe colon. What could we use to differentiate?
Three layers of muscle.
1, 2, 3. There's your 3 layers. It's got to be stomach. Which means all of these mucosal glands are called gastric glands. There's holes that lead into those gastric glands, and those little holes are called gastric pits. The cells that form the surface epithelium also reach down and line the pits, and those are called mucus cells, surface epithelial cells. How are those different from the mucus neck cells that are a little further down? And they're kind of blending them together here. They secrete an acidic mucus, whereas the surface epithelial cells secrete an alkaline mucus. They're not really distinguishing between the two, though. And then when you get into the glands, in addition to mucus cells, you also have chief, parietal, and enteroendocrine cells, G cells in particular. So it's hard to tell what's enteroendocrine and what's chief, because they only give us 2 really distinct cells. But these really big red ones, parietal cells, definitely. Parietal cells are quite large. But other than that, it's a mixture of G cells and chief cells. We can't tell from the models what's what. This little round thing here, it's a little moon.
What is that?
Here's a big moon. Here's a little moon.
Follicle?
It's a lymphoid follicle or lymphatic follicle. Yeah, it's just not very big. But you find them throughout the entire gut. So yeah, it's part of gulp or molt. Flat, has serosa, only 2 layers of muscularis externa. Can't be stomach, no villi, can't be small intestine. Simple columnar epithelium, can't be esophagus. Colon, large intestine. The white cells, goblet. There should be, by the way, and there isn't, but there should be way more goblet cells on this model than the small intestine. That is a difference between large and small. Large has way more goblet cells. These models show about equal numbers of both. Similar, thinner wall, bigger follicle, otherwise pretty similar. This is a modification of this. This is an outpocketing of this.
Appendix?
This is appendix. So the histology is very similar to the rest of the colon, except the wall is thin, and most of the submucosa is taken up by follicles, huge aggregates of follicles. So this is appendix. Stratified squamous, flat, must be esophagus. Little adipose here. Adventitia at the bottom, no serosa. Submucosal glands with a duct to get the secretion to the surface. What are these submucosal glands called? Esophageal glands. What do they secrete? Lots of mucus. So we've got a little bit of that, and then we've got a little bit of this. So this is the transition from pharynx to esophagus or esophagus to stomach. So we're at the transition. We don't quite yet have all three layers of externa, so just a circular and longitudinal. So don't let the fact that there's not three there make you think that this can't be stomach. We're just transitioning into the stomach. So we are beginning to see some gastric glands. And you're seeing the submucosal glands disappear. Right? There are no submucosal glands in the stomach. What would you call the junction between the esophagus and stomach? And what is right there at that juncture? Cardiac sphincter. And you do have a relatively thick layer of circular smooth muscle, just not as thick as the pyloric sphincter. This model is showing 4 regions in one model, but there are issues with it. What's the top here with the submucosal gland? It's got a duct going to the surface. Esophagus. You can also see the stratified squamous epithelium. And then it goes to simple columnar here, here, and here. Here, those bumps are villi, so this must be, right? So you have esophagus, small intestine. So this should be, those are gastric pits, gastric glands. The problem is I only see 2 layers of muscularis externa. The muscularis externa here looks the same as it is there and there. So, mistake. There should be 3. And if this is small, then what's this? Large. At least they show more mucosal glands. That's good. What are these purple things here? Mm-hmm. Yeah. Lymphatic follicles. And then as far as the outermost tunic, serosa, serosa, serosa. But here, you're missing that epithelium, so this is adventitia. As it should be. That's esophagus. And then they do a little microscopic anatomy on the back side here. So this gland is a submucosal or esophageal gland. This gland, gastric gland, it's a mucosal gland. These red ones should be the parietal cells. This one, it's the luminal membrane. That should be a chief cell because the vesicles are the luminal membrane. If the vesicles were at the basolateral membrane, then it should be an endocrine cell, yeah, an enteroendocrine cell or a G cell, because the hormone's going to go across the basolateral, not across the luminal. Mm-hmm. And this gland here, intestinal gland or intestinal crypt. I wonder if this is a Paneth cell. Not really sure. And then same thing down here. Intestinal gland, mucosal glands, intestinal crypts. But since this is large intestine, more goblet cells. Oh, that's what these red ones are. So up here it's parietal, but these ones down here, these are goblet, and they did put more in the large intestine, so that's good. That's definitely the case. How about this area where everything's entering and exiting the liver?
Hillis?
It's not hilum or hillis, but it kind of means the same thing for the liver. The port of the liver. Porta hepatis or porta hepatis. Okay.